Okay, before starting today's lesson, so this is quite the important part actually, because we are going to start the traverse correction. Right. Just a moment. Okay, there are some students have mentioned that they have some connection problem due to bad weather condition. So I'll be uploading the session into the LMS, so it will be cleared this week. Somehow I will be clearing it and will be ready for your batch. Right. So before moving to today's one, is there any problem with the previous problem I have given you, not as a quiz actually, right? I gave you this question. There are two questions. Right? Did anybody tried and have any problem? So I will be sending you the work example for the first question and allow you to do the second. And remember, this is not only a chapter, it is a very basic component in all the 7 sections. Right, you have to deal with these coordinates and bearings. Right, that's why I spend that much time to explain this one and work out. And I told everything, right, how to manage with your calculator and everything. Right. So is my voice clear? Can you hear me?
Yes, sir.
Okay, thank you. Right, then we'll be moving to today's part, that is traverse. Right, now I have gave you a brief about the land surveying. Right, I have given you basic about the land surveying techniques, and I told traverse correction or the traverse survey is the one which is specified for our curriculum, or not in your one. In most of the surveying curriculums, even in engineering one, right, and at Excel and City and Guilds, everywhere, right, this traverse correction has given very that means the priority has been given to this one, because that is a good technique to apply for any type of land, whether it is open or small or whatever, or with the disturbance in the mid, you can apply it for any kind of land. Right? For the other techniques, there are some limitations, right? Triangulation or chain survey, trilateration, they have some limitations. But for traverse, we don't have any, right? For this case, actually, it is very difficult to prepare slides. So I have prepared only a small work example, right? Then most of the things would be explained in the whiteboard. So you have to, I think it is better you make your own notes, right? And try to understand the concept, because you have to, once the faculty reopened, we start our field classes, then you have to do a traverse survey with all these calculations and prepare a drawing, prepare a plot of the given land. You will be grouped into maybe 6-7 members, right? and then you will be given a particular separate land plot. Then you have to do all the survey using this technique. So traverse survey, so we have to start this one in detail. So today's topic would be traverse surveying. Traverse surveying at least, actually what we have to do is the traverse survey calculation, right? Traverse surveying calculation. So what is traverse survey? If you want to, if I want to brief out what is traverse survey, that is right. So what you have is a polygon, right? And in traverse surveying, what we measure are, so these are your measurements. And we measure all these lengths and angles, right? For this case, it is a 5-node polygon. So we are measuring 5 angles and 5 lengths. And I have told you, you have to measure one whole circle bearing. One whole circle bearing need to be measured. That is for the orientation purpose. So with these measurements, how we can plot? So under the traverse calculation, what we discuss is how to take or how to draw a small scaled polygon in the piece of paper. In the field, we measure these 5 angles and 5 lengths with the tape or EDM while we explaining these measurements later with the equipments. For angles, you will be measured with the theodolite. That will be again explained separately how to handle the theodolite, the in and outs of theodolite. Right, you will be using a theodolite to measure the angle, each angle in the field, and with the tape you are measuring the length, and with the compass you are measuring the bearing. Right, then in the particular direction, let's say this is the north direction in the field, so you have to clearly or correctly draw a polygon to a suitable scale. Let's see how we can do this. For that, there are two methods. There are two methods available to draw this polygon in a piece of paper. Right? The first one, it is quite difficult to apply, but for the completeness of the module, right? For the completeness of the module, I have to explain all. Right? The first method, right? The first method is, I'll rather use okay. First method is graphical method. Remember, here we are discussing how to reconstruct this polygon in a paper. First method is called the graphical method. Remember, this graphical method is quite difficult. After I explain the procedure, you will realize why it is difficult. Right? So I'll explain it step by step. Steps you have to follow if you are going to apply the graphical method, right? Remember, now you have 5 angles and 5 lengths and a bearing in your hand, right? In your hand, you have 5 angles, 5 lengths and a bearing and a paper. Let's say A4 paper or A3 paper, whatever. Then what you have to do, right? So I will explain one by one. step 1 or simple A, first you check whether your angles are correct. Now you have 5 angles measured in a closed polygon, and what you have to do is you correct your angles. Correct angle. Right? Correct the angles. How you can correct it? Oh, why you need to correct, first of all? Because we measure each angle separately, individually, so they may contain some errors. We will discuss these errors in a separate chapter. Errors not only in angles, in all the measurements. Right? So that is a different topic. We'll be discussing it under the errors. Right? For the moment, you may know once you take any measurement, it can be length, it can be angle, it can be time or volume, whatever. They may contain some errors. Right? They may contain some errors. Right? So if you recognize these errors, then we can correct. In this case, so can you realize whether these measurements contain any error? Of course you can, because we know we have measured internal angles of a polygon. Then we know, so how we can correct? You take sigma theta. That is theta 1, theta 2, theta 3. Likewise, you have the internal angles, etc. Never mind how many nodes you have, but they should be the internal angles. Then you can correct them. So first you can sum up. You can add all your internal angles. Then how you know that they have errors or not? Right? Because you can compare it with the theoretical value. What is the theory? So this is called the measured sum. This is called the measured. This is your measured value. Right? You have the measured sum, and to compare it, you have something in your hand. To realize whether it is correct or not, you have to have some standard value. Then only you can compare and check the error. Right? Here also we have something called the theoretical sum. What is theoretical sum? The theoretical value, the correct value. Right? If you have a polygon with n nodes, n number of nodes, right? The theoretical sum should be the theoretical value, or the standard value should be n minus 2 into 180 degrees. It comes like this, right? So these are not a very advanced or very complicated techniques. So if you have any polygon, for this case, you have 1, 2, 3, 4, 5, 6. For 6 node polygon, right? If you divide these into triangles, in any means. You can divide it in any way, doesn't matter. If you wish, you can divide it this way. Right? And when you take the sum of all the angles for this triangle, the sum of all these dots, now there are 4 triangles. The sum of the angles of a triangle is 180. So you have 4 triangles, right? When you sum up all these dots, right? So this dot and this dot will create the angle 2, angle 3. So there are 3 dots containing angle 4. So angle 4 you can subdivide it into 3 parts, but somehow here you see 4 nodes will create, sorry, 6 nodes will create 4 triangles. So that's why you have n minus 2. N minus 2 number of triangles. Each triangle is 180. Therefore, sum of all the internal angles should be equal to this. Right? Now you have the expected value, theoretical value, and the measured value. What you have measured and what is the correct value. If you have any difference between your measured value and the actual value, that is called the error. Right? That is called the error. Error in which way? Right? Is this part clear? Right? So we are going to correct our measured angles. Right? We are going to correct the measured angles. For that, you have to have the measured value and the actual value. The actual value is n minus 2 into 180. Right? Then the difference can be taken in 2 ways. 1 minus 2 or 2 minus 1. If I take this quantity, you add all your measured values. So I take this as 1. And this is the expected value. If all your angles are perfect, you will end up with this one. So I take this as 2. If they are different, right, the difference is called the error. Right? That is called the error. But that error can be taken in 2 ways. One is 1 minus 2, or the other is 2 minus 1. They are not same. You have the same quantity, but plus and minus. For example, if the first quantity is, let's say, 179. If 2 is 180. For the first one, you get minus 1 degree. For the second one, you get plus 1 degree. So they are not same. Plus 1 and minus 1, they are not same. Quantity wise, it is same, but they have opposite signs. So what is the error? Right? Remember, error for any measurement right? Now we will be discussing this error in most of the cases, right? In most of the cases, leveling, traverse, angle measurement, length measurement, in everywhere throughout this syllabus, not only in surveying. In the other measurements also, we have to calculate the error. So we have a common equation for the error, right? To find out the error, I told you have to have two values. One I call the measured quantity, and the actual quantity or the expected value. So let's say for this actual, you are having two values, measured value. Then my question is whether this error is measured minus actual or actual minus measured. If it is in the classroom, then I may take your answers and check whether. So some may raise for the first equation, some may raise for second. I told that they are not same, right? Measured minus actual and actual minus measured, quantity wise same, but sign wise they are different from the sign. So what is the equation for error for any measurement? Not only in survey. For any measurement, error is, now let's say, to understand this, right? There is a measurement. Let's say there's a ruler, right? The actual one is 30. The actual measurement is 30. So we know the actual one and we are going to measure. Let's say I ask two students to measure this one. So one group of students measure it as 31. So this is first group. So their measurement is 31. The other group measured it as 29. So both are possible. So this is the second group. They measured this as 29. One group is 1 unit above, the other group is 1 unit below. For the both groups, the actual one is 30. Now, how I express the error for the first group? When I give marks, I have to say, you have measured it with 1 unit excess. You are 1 unit above the expected value. For the second group, I have to say, you are 1 unit below. Quantity wise, both groups are same, right? Their off is same, but one group is above, one group is below. So for the first group, I have to say your error is +1. But I say you are 1 unit above. For the second group, I have to say you are 1 unit below. That below comes with this minus sign. So this is the error. How that error comes? This 29 comes when I take 29 minus 30. This +1 comes when I take 31 minus 30. Because 30 is the base. This is the reference. I have to take the difference with respect to 30. Right? Therefore, remember, for any measurement, error is, equation for the error is measured minus actual. Error is always, error is measured minus actual. So it will end up with the sign. It is okay. Like in this one. One group is +1, one group is -1. The error can be plus or minus. You can be above or below. Sometimes you measure above the expected. Sometimes you measure below the expected. So say above or below, in science we use plus and minus. Or it comes with this general equation, error is measured minus actual. Right? So this is a very important equation or relation with measured and actual quantities to find out the error. It is a universal equation, not only for surveying. Not only for surveying, for any measurement, it will be measured minus actual. Hope this is clear. If you have any question, please ask. Okay. Now what I want to do, now we come back to the step A, the first step. What you want to do? Shall I erase this? Now we come back to a step, the first step, correcting the angles. Right now you know your measured value and the reference value. Then you calculate the error. So this error is called angle misclose. This is called angle misclose or error in the angle misclose. In surveying, right, we call angle misclose or angle error. Error in your angles, right? Angle error, which is equal to sigma theta. Sigma theta minus n minus 2 into 180. Then, right, so this is the total error, because for one angle you cannot find out which is the correct one, right, which is the correct one. So you have measured 5 angles, and with this total you have end up with this much of error. Then what you can do, now you have to correct it. To correct, what you have to do, you take the negative of that error. That is called the correction. There's another equation, another relation we have. The correction is negative error. Right? Because if you find out that you have taken excess, then you have to reduce it in order to correct it. Correct it means you have to reach the reference value or the actual value. In order, the action you are taking to take your measured value into the correct value is called the correction. Right? To correct, what you have to do, if you are above, if you have a plus error, then you have to reduce it. If you are below, you have to recover it. That is the correction. Right? So you can find out the correction, or you can write the equation for this one. This is actual minus measure. Right? If the error is measured minus actual, when you substitute, you will end up with actual minus measured. That is the correction. Right? So we know always correction and the error, they are the plus and minus of the same quantity. Right? Now you can find out the correction either with this equation, or you take the negative of error, right? Negative of the error, and how you can distribute. Now you have 5 angles. You have to distribute that among the 5 individual members or whatever the number of members. That is called error distribution. Now what you have to do is distribute the error. There also we have a theory, not a big theory, because we are applying this in our day-to-day activities. When you take the error distribution, right? Error distribution can be done in 2 ways. We have 2 methods to distribute the error. So for this case, we have to understand which one is the relevant one. We have 2 methods. One is called the equal distribution, right? One is called the equal distribution and the other one is called the proportional distribution. Right? Equal distribution and proportional distribution, these are not big new theories, but we should know how to correctly apply it. What is equal distribution? Equal distribution means you have 5 members with different quantities, right? You don't consider the quantity, just distribute it equally. I'm sorry that there are some background noises, right? Can't help, right? There are some works going on around me, right? I cannot shift, right? So I continue and I apologize for the disturbances, right? Equal distribution means you don't consider the quantity, just consider the number of members and distribute them equally without considering the size of the member. Now we do this in proportional one. What we consider, there is a high portion for larger ones and less portion for smaller one. That means you consider the quantity and you divide it according to the size. According to the size. So you consider the effect of size and distribute it. That is called proportional distribution, right? If you don't consider the size, it is equal distribution. Now how we are applying it? So we are applying it not in error distribution. In some collections, let's say when you are collecting money for some activities, you collect it for number of head. Let's say your course fee, or you are collecting, or you are going on a trip and you collect the fee. You don't consider the size, a student or number of heads. If you are collecting the money for meals, then you say per head. You don't consider whether it is a large person or smaller person. They all have equal share. In some cases, let's say you are printing a t-shirt, you may say the small size is this much, medium is this much, large is this much. So we know with the increase of the size, the cost may change. Right? And then you say, okay, we have this much. Then those who use large size, they have to have a larger share. Right? Similarly, in measurements also, we consider whether we have the error increasing with the size. Right? In this case, we have 2 types of measurements, lengths and angles. So what do you think? For example, take angle measurement. Do you create large error when you are measuring large angle? Let's say you are measuring 30-degree angle and 60-degree angle. Do you have large error when you are measuring the large angle? Obviously, no. Right? Because you have 360 degrees consecutive constant value around the point. So it cannot be going larger. Somehow you have only 360. Therefore, but when you are measuring a length, so if you measure smaller length, smaller distance, your error will be small. When you measure large distance, it would be large. Right? Therefore, we usually use angle measurements as equal distribution. When we are correcting for angle measurements, we use equal distribution. For length correction, next time we consider the length also. Right? For the length correction, we use proportional, assuming when you measure larger distance, you create large error. So that is obvious. So if you, let's say you have a tape, if you extend the tape, if you pull it a little bit higher than the standard tension, right? Let's say you have a 10-meter tape and you extend it up to 11. You take a large pull and you made it, then all your measurements would be multiplied by a factor 1.1 because you are extending 10 meter into 11. Right? Then you are reading 10 as 11, 5 as 5.5. Right? All your readings would be the real one multiplied by 1.1. When you measure 1 meter on the tape, it would be 1.1 meter. If you extend the same tape. But for theodolite, it is not like that. So it is mostly the reading error. Because you keep your protector 360, whether you heat it or cool it, you cannot expand. Even it is expanded, you have 360. Right? You cannot make a 10 degrees into 11 degrees by changing the ruler or protector. Right? You cannot change the scale like that. Therefore, practically, hope it is clear. When you take angle measurement, which usually we use equal distribution, and for lengths, usually we use proportional distribution. Now what you have to do, you know the error and you have number of members, number of angles, and then you distribute this correction equally among the angles. So first of all, you have to correct the angles. Now I have explained a little bit in detail because this would be needed in the other sections also. So that's why I explained it in detail, right? So what you have to do, you find out the error and then the correction, or directly you can find the correction and distribute it among the individual members and correct the angles. You have to correct the angles. That is your step 1.
Excuse me, sir.
Yes.
Sir, simple n means
Number of nodes.
number of nodes.
Number of nodes. For this case, you have 5 nodes.
Okay, sir. Thank you.
In our polygon, we don't know how many nodes are there because it is changing from site to site and person to person. Right? But if you measure all the internal angles, it should be this much. It should be this much, n minus 2 into 180. That means if you measure angles of a triangle, 1, 2, 3, The summation should be 180. That is the actual summation. But when you add your angles, your measurements, it will not be 108, but it should be close. It should be close, right? It can be 150. It will be 179 something or 180, 181, something like that. Very close to 180. Otherwise, it is not worth correcting, right? There can be a small error that is called the angle misclose. Errors of your angle measurement. It should be a very small one. But there is an error. That error can be distributed and you can correct the angles. After the correction, the summed angle should be equal to the theoretical value. Clear? Any question? So under the graphical method, what you have to do, first you have to correct the angles. I told now we are going to do this with by having set of angles and set of lengths. The numbers in your hand and the bearing. With this, right, what will happen if you just draw it? If you just proceed, what will happen without doing any correction? Right? The last time I explained that you can do it. If you just plot, what will happen? You draw the length and next angle. Likewise, because these measurements will have some errors. Because of that, what will happen when you draw the last one? You will end up with somewhere there. You start with A here, B, then draw the line AB, scale length, then the angle, the row values. If you try to proceed with row values, what will happen? You will end up something like this. Practically, it will not be close. Right? I don't know whether sometimes it may go somewhere there. Somehow, it will not be close. A dash somewhere there or there. Make a creating an error. Oh, it is not closing. Your polygon is not closing. So that's why we want to do some correction. Right? You cannot just link the last one and to the first one and say it is okay. Right? That's why we need to have some corrections. For this correction, actually what we do, right? There are two methods. The first one is just for your knowledge, right? Saying that there is a method, otherwise the module will be incompleted, but it is quite difficult to apply. So that is what we are discussing now, the graphical method. Right? So we are discussing about the graphical method. In the graphical method, I explained the first step is without going for the drawing. So before going for the drawing, you have to correct your angles. Still, you will not get a close polygon because your lengths are also wrong. You have two set of measurements, set of angles, set of lengths. Both contain errors. Both contain errors. Clear? So the first step is correcting the angles. So what you can do is, let's say your first angle, number one is, let's say 85 degrees, 23 minutes and 10 seconds. The second one, something like this. And if you find out there is a plus 2-second correction for all the angles. Let's say you have 5 members and you have 5 such values and the summation has minus 10-second error. Let's say error is minus 10 seconds, then the correction is plus 10 seconds. That is the total correction. Then the correction per angle is this divided by 5. So you have to divide this 10 seconds equally among the 5 members. So it would be plus 2 seconds per angle. Then you have to add 2 seconds for all. You also this angle plus 2 seconds. Third angle plus 2 seconds. So you are going to add 2 seconds or the correction for all your angles and correct them. Thereafter, your angles are corrected. So your corrected angle 1 is 85, 23, 12. 25 degrees, sorry, 85 degrees, 23 minutes and 12 seconds. So that is the corrected angle for angle 1. Similarly, 1, 2, 3, 4, all the angles can be corrected. After that, the summation of the corrected angles should be the theoretical value. Any question? Okay, then we come to step B. The second step is, now you take your drawing sheet. Actually, this is a construction one, right? We do this in by having a constructed drawing. So what we have to do is we have to select a scale. So how to select a scale? This is trial and error. Some people may select the scale from the first attempt. Some people try to draw it. Then if it is wrong, you have to change the scale and redraw. So this is another disadvantage of this method, because you cannot select the scale at the first step because it is random. Randomly select a scale. We don't know whether it is the final, right? Or we have to change it in the middle. So part B, the second step, randomly select a scale. If you write down, better note down. The second step, randomly select a scale. You better note down. First one is correct the angles. I have explained all the procedure of how to correct it, right? What you have to do is, first you correct all the angles, and second one, randomly select. So random means by experience, or you select something, then at the mid you may have to change it. It is not the final scale. Like somehow you have to select a scale. After that, what you have to do, right? Part C, better note down. Construct the figure. Construct the figure using construct the figure using corrected angles and measured lengths. Construct the drawing using corrected, so that is the point to be highlighted, corrected angles and measured lengths, because we have not done anything for the lengths yet. So lengths are raw, but corrected angles have been corrected. So what we have to do, starting with the line with the bearing. Definitely you have to start with that line. So you draw the first line, right? Then draw the corrected angle and the next line, the next angle, the corrected one, and the next line. At the end, what will happen? So this is the important thing. At the end, you will be end up with, when you mark the last angle and the last length, you will end up with unclosed polygon. It can go somewhere the other way also. It may cross somehow. It may not come to the expected point or the origin. You start with A, mark AB. Let's say AB is the line with the bearing. Then you mark angle B, corrected angle B, and go to C, go to D, go to E. When you mark point E and the length EA, you will not come to point A. So we mark it as A dash. It will be a smaller one. We don't know where this A dash lies. It can be anywhere, right? But I draw just one possible way. Sometimes, remember, it may go somewhere there and stop A dash here. Somehow it will not come to the A practically. So once you make this step C, you will end up of this type of figure. This type of figure. A misclosed polygon. And we cannot say a polygon also. Misclosed figure. Then, so is this clear? You manage with data what you have, the original length measurements and the corrected angles, because we have find out the error, but the thing is you cannot find out the errors in the lengths, right? Then what will happen? The next step is you want to correct it. How you can correct? Not just linking E and A. You cannot do that because we don't know where the error is. You cannot give the total responsibility to angle EN, length EA. All the other parameters are also responsible. There should be some effect for all the points, right? So this is the procedure. Please look carefully how we are going to correct it, right? So this figure, what we do is thereafter we have a small construction. What we do, we just connect A dash and A. So our total, our procedure of correcting is taking A dash to A. So this is the final one. But you cannot just take A dash to A and connect EA. Finally, this A dash should come to A. As a result, what will happen? All the other points also disturb little bit. How? Right? So this is just a assumption and one method developed by one professional. right? So what we do, we draw parallels to this A dash A line from all the points. This A dash should be taken to A, and as a result, all the other points also shift little bit. So we assume that all the points will shift parallel to A dash A. So what we do, we draw parallel lines from all the points. And then you have to mark the distance, right? There what we do. So I will actually no need to write these steps. If you just draw it, that is enough, right? So what we do, we draw this one and we create a figure like this. Let's say this is L1, L2, L3, etc. Right? So what we do, we draw a line and let's say this length is E. This misclose is E. There is a total. So we call this E as the linear misclose. Linear means length, because now we have corrected all our angles. All angles are corrected. Therefore, this error we can totally claim on length measurements. You have two set of measurements, angles and lengths. Angles are corrected and still you get some error. If the angles are corrected, then the total responsibility will be on length. Let's say there is a classroom, girls and boys are there, right? If there is anything happen, you cannot say whether it is by boys or girls. But for any case, if the girls are out, then you can say that error or that problem created by boys. Similarly, in this case, there are two types of measurements, right? The total error can be created as a combination of both, but angle parts are already corrected. Angles are corrected, only lengths are remaining. Therefore, this error is due to the length. So we name it as linear error or linear misclose. So this misclose is not a good word, something like Miss World or Miss Sri Lanka, right? So here the term of the preposition miss is used for the bad side, right? It is not closing. To say that it is not closing, to say that bad side, we use the preposition miss. Right? In your groups also, there would be some miscloses. When we start our field work, you may find out, right? Okay, so what we do, so you have this length, then in order to find out the shift, what we do, we draw a linear scale with L1, L2, L3 in one line. This scaled lengths can be plotted along one straight line, L3, L4, L5. I will mark it on the bottom, L5. to the correct scale. So what we can do is just take this length, because it is the scale length is there. You just take this length and mark it along a straight line. And also the distance E. We create a figure like this. The idea would be clear. So what we are going to do is we are going to use the proportionality, the proportional distribution for this one. And what we do, I take these shifts as 1, 2, 3, 4. And this length will be marked. The 1 would be marked there. 2 would be marked along this line. 3 along this. 4 along this. And 5 means it is E. So as a result, this A dash will come into this point. Then connect all these shifted points. I use this yellow color. This yellow color polygon is called the corrected polygon. The corrected polygon is taken as this yellow color one. Now you can see the shift is very small for B. For C, it would be a little bit 3. As we are taking the cumulative one, right? So this is the construction to get the corrected polygon by using the graphical method. You can see it is very difficult to use because you have to mark all the angles, and this figure also very untidy because you have parallels, lengths and everything marked, right? And the scale selection is random. Sometimes what will happen when you select a scale in your paper, right? When you try to draw your polygon, it comes somewhere there. So you will see at the end of the paper is then your scale is not good. So you erase everything, select a smaller scale and redraw. Or sometimes when you draw it, you will get very small figure. That means it is not a very good scale, because we know if you increase it, you can draw the figure a little bit larger, because everything is random, right? We call trial and error. You try something. If it is wrong, you restart by referring to that, right? Sometimes you see when you try to draw it, at the end, the paper is not enough, right? So there are so many disadvantages in graphical method. So we are not going to practice it. anymore. But remember, there is a method. In some cases, if you use AutoCAD, you can do it. You can do it, but when it is manual, very difficult because right. So there are so many disadvantages in this method, right? One is it is very difficult to select the scale and difficult to mark all the lengths and angles, right? These shifts are very small, even though I draw it very large. Right? Even though I have drawn it with exaggerated manner, they are very small shifts, right? Then very difficult to mark. And the last one is the paper, the figure become very untidy. You have so many constructions. You have the uncorrected polygon, corrected polygons, shift, everything marked. Therefore, the figure is untidy. Right? Therefore, we are not going to use this method very regularly. Very difficult. It is quite difficult. So, we'll be using the other method. Actually, what is given to you in your curriculum is the traverse calculation sheet, right? So I think you have some idea about this method, right? For your for the completeness, you should know that there is a method, right? But and also the practical difficulties of using that method, right? With that, we move to the other method. So I told that we are going to discuss two methods. This second method will be the method you have to follow. You have to use it in your field classes, and this question would be there in your examination. For the examination also, you have to complete the traverse sheet. Right, this calculation technical one would be there, and you have to do it with your own measurements in your field classes. Is it okay? So can I erase this figure? Is it okay? Right. Therefore, we move to the second one, the second method of drawing the traverse sheet correction that is traverse sheet. This one again I will be explaining with an example. Traverse sheet I will be explaining with an example. Right? Okay, there are some rules. There are some steps you have to follow, right? I have explained that in this lecture note. For the steps and everything have been explained for this method, as it is very important, right? So let's see. So we will be doing this with one example, right? One example. So this, let's say this is the example. ABCD, that is 4-node polygon, anticlockwise. Anticlockwise means ABCD noted in anticlockwise direction. And I will explain why it is why it should be anticlockwise, right? And there are 4 angles and 4 lengths. ABCD internal angles have been measured and given, right? And the length AB, BC, CD, DA have been given, and the whole circle bearing of AB has been given, 45, 20, 20, right? So if you just figure out this, you can now if you want to apply the graphical method, you can follow, but we are not going to do it with the graphical method. But if you wish, you can try it. Even without AutoCAD, it is very easily you can do it. Then you can maintain these angles and lengths also. Right? So let's see what we have to do. The first one is, right? So I think you don't need to. So it is better you just note down these 9 parameters, and we are going to fill it. Right? I will give you the format of the traverse sheet, and we will fill it as we explain. So at the end, then you will be filling this traverse sheet. Right? You will be filling it. So we will discuss first. So I give you 2-3 minutes. Please note down these parameters. So we are going to work out one example completely. Right? So I will explain this with an example. The traverse calculation. Let's say 4-node polygon, 4 angles, 4 lengths, and a bearing. So please quickly note down this. Just the numbers A, B, C, D, length A, B, B, C, C, D, D, A, and the bearing. But and the next one, I'll be right. The first step is again we have to do the angle correction, right? Calculate the angle error. I have explained everything, and it is mentioned here also. But in this traverse sheet, you should not do, or it is not necessary to do this angle correction separately. You have to do it, but in the traverse sheet itself, we can do that, right? When we complete it, we can do the angle correction in the traverse sheet correct itself, right? So it is clear that the total correction n minus 2 into 180, that is the theoretical value or actual value, and sum of internal angles, that is the measured value. I have explained it in detail, and the correction per angle is total correction divided by n, right? Then the linear correction, the graphical method, and the traverse sheet, or we call the Bowditch method. Bowditch method is the name you can find out in your course outline. On the detailed curriculum sheet, you can find out this Bowditch method calculation. Right? So we do this Bowditch correction using a standard traverse sheet. So this is the standard traverse sheet. I prefer you to again prepare this type of traverse sheet, then we will fill it. Right? For the filling, I just explain the headings. First, don't write anything, just look at. The first one is the station, line, the second column, observed angle, corrected angle, whole circle bearing, length, delta I, delta n. I have explained that under the bearings, right? The previous sections. For whole 2 days, we were discussing delta I, delta n. Then corrected delta I, delta n and coordinates. So these are the headings. So now what you have to do, you prepare a sheet, right? The sheet should be done in this way, right? So if you, it is better you take a ruled sheet, right? Ruled sheet. Then for these columns, for the station, line, angle, observed angle, corrected angle, whole circle bearing, length, delta I, delta n, corrected delta I, delta n, and coordinate. So I just give you the expected width. So this is station, line, observed angle, I will show you the headings, right? Then the corrected angle, whole circle bearing, length, delta E, delta N, then corrected delta E, delta N, and their coordinates. I want to just explain the expected width for each column. This is meters E and N. Meters N. For the first column, we are entering just one letter. So it can be very narrow. Only one letter. For the second column, line, we are entering two letters, two characters. So this is an angle. Angle is degree, minute, second. So you need the space, degree, minutes, two letters, seconds, two letters. Right? For the corrected angle also same. It is degree, minutes, and seconds. For the whole circle bearing also degree, minutes, and seconds. For the length, it should be wide enough to enter maybe up to 3 decimals. So your values, you can see what the values you have noted. Lengths are 59 point something like that. So delta I, delta n all are in the same order, the same width. Right? For the coordinates also, each column we have to enter the same width. So these are the expected widths you want to. So when you prepare this table, don't make all the columns of equal width. For the first two columns can be very narrow because you are entering only one column, one letter. For the second column, two. Then the next three columns, they are angles. So angle should be degrees, minutes, and seconds. You should be able to enter them in horizontally. So you prepare a table roughly, and better you have to have at least 10-11 rules. So you have to have rules, maybe 11 or 12 rules, rows are necessary. Right? So you need up to, let's say, about 12 rows. Better to have the, or either you can take a square rule one, or if it is a CRO or something, then you better take 2 pages together and draw this table. So once again, I give you 2-3 minutes to prepare this table, right? And we are going to, so I'll be explaining the procedure. At the same time, we are going to fill this. So please have your calculators also, right? Please have your calculators, and we are going to fill it as I explain, right? Okay, so then if you need the full titles, so this is the traverse sheet, right? So here the angles have been divided into degree, minutes, and seconds. Okay, please so please have it. I will give you a few minutes to prepare the table, and after that we will be filling it. Okay, so please have this sheet prepared. Right? Hope you can. So I have worked out one traverse sheet from the Excel. So let's say so this is the traverse sheet we are going to fill. And have you prepared it? So are you ready to fill this with the given raw data? Don't fill anything other than these headings, because there are some rules. So we are going to apply them one by one. So I have explained all this in this lecture note, right? And we are going to fill step by step. At the same time, we are going to fill the real traverse sheet. Are you ready? Right. So these are the rules. These are the proceeding. So there are 7 steps. When you complete the 7 steps, the entire sheet have been filled. And you will end up with the coordinates. Then only we are moving to the drawing sheet. So that is the advantage of this traverse sheet. Right? You don't have to touch the drawing sheet until you prepare the corrected coordinates. Corrected coordinates, right? So we do everything on the calculation basis, and then only we can move to the we are moving to the drawing sheet. So these are the rules. Enter the lines and stations. I will explain. Don't enter anything. Enter the lines and stations in anti-clockwise direction. Right? I will explain why. In each alternative row, starting with the line having the bearing. So it will be unclear, so don't worry. Right? Enter the lines and station. The first two columns have to be filled. It should be in anti-clockwise direction. So these are the rules to enter the lines and station and lines. Right? So when you have a polygon, whatever. Let's say this is your polygon. Right? It can be any of any shape with any numbers, doesn't matter. Right? You are having one line with the bearing. Let's say you have measured the bearing of this line. Let's say this is north. And this is the bearing. Right? We have to consider everything in anti-clockwise direction. That means our notations should be going from, if the notations are given, let's say A, B, C, D or whatever given like this. It is better if you have all the notations in anti-clockwise direction marked E, F, G, H, whatever. Right? And so we consider we are moving in anti-clockwise direction. So this is our direction of movement. We are starting with one point and going in the anti-clockwise direction and come back to the same point. Right? So this is the order of our movement. It should be anti-clockwise. Right? And there is a line. The bearing should be in the forward direction. For the forward direction for this line is CD. When you move anti-clockwise, it should be CD. For example, if you have these numbers put in this way. Let's say you have marked your notations this way. You have started from there. A, B, C, D, E, etc. E, F, G, H, whatever. Still, our direction of movement is anti-clockwise. Then you have to start with CB line. Now your direction is CB. Because the line with the bearing is BC line. And the bearing you need is 5CB. If you have measured the other bearing, sorry. Right? If you have measured the other bearing, let's say not by mistake, if you have measured this bearing, 5BC, you need 5CB in order to fill this traverse sheet, because CB is our movement direction. We are moving anti-clockwise, so when you come along this line, you are moving from C to B. So CB is our first line. Right? So there are three conditions. One is anti-clockwise movement. Should be anti-clockwise movement. Right? Then start with the whole circle bearing, the line with the whole circle bearing in the forward direction. Right? In this case, you have to start with CB. After CB, you are moving to BA line. So this is our movement. CB, BA. So if you have marked everything in anti-clockwise direction, it is very easy. It is very easy if we mark at the beginning. So when you do your traverse survey, please mark them in anti-clockwise direction. Anti-clockwise direction means we mark our notations in this way. It is very simple then when you go for completing the traverse sheet. And when you can select any line, then so this is your movement. So when you measure the bearing, measure it in the forward direction. Not CB, please measure it in this way. Then this is the line you are starting. So your first line should be BC. You are starting with line BC. So this is a rule. The line with the bearing should be on the top. Right? So now consider your movement. Don't write anything. Don't write anything. You consider your movement. So you are moving along this line. So how you move? After a line, you come to a station. So station means this node. Station means this node, then line. After this line, you come to this node. Then this line and this node. So along your movement, you move from line to a point and point to a line. So line, point, or line, station, likewise you are moving. Right? So you have to fill your traverse sheet in that order. So how we start? So you have two columns, station and line. Station and, so there are two columns, station and line. Right? Then how you fill? You start with BC. After BC, you go to a station called C. So that should be in the next line. Station and line cannot be entered in same row. Right? Then after C, you move to line CD. CD line. Then station D. Likewise, you have to fill the first two columns. Hope it is clear. Start with the, consider the things in anti-clockwise direction. Start with the line with the bearing and fill it according to your movement. So the advantage of marking the points in anti-clockwise direction is you don't have to see the figure then. If you mark A, B, C, D, E, F, G, H up to, let's say, 20 points, right? So if you start with BC, then we know it will be station C next. Then CD, station D, DE, E, EF. So you can feel, or sometimes we put P1, P2. Normally we put P1, P2 because if you put A, B, C, D, you have to limit it to 26. If you have more than 26 nodes after Z, then you are in trouble. Either you have to go for A dash, B dash, or A, B, etc. like in number plates, vehicle number plates. But if you put P1, P2, there is no limit for 26. You can go up to any number of stations. So what we do, we normally put them as P1, P2, P3. Primary stations P1, 2, 3, 4. Then if you start with, let's say P3, P5. P3, P4. Then we know next you go for P4. Then P4, P5. So I don't have to look at the figure. Right? How many numbers you have is not a problem for me. If I number them in anti-clockwise direction at the very beginning. So you are asked to, or it is recommended, when you put these numbers for your own survey, when you put numbers, notations for your survey network, please put them in anti-clockwise order. A, B, C, D, or 1, 2, 3, 4 doesn't matter, but maintain some order, because that way will make the calculation easy. So you will not get many mistakes, because after that we are just following the table, right? We are just following the table, so it is easy. Now come back to your one, right? Is this statement clear? So you have to start with, right? Now come back to the step. It says enter the lines and stations, that all, in anti-clockwise direction of clear in each alternative row. So you have to have line and station in different rows, right? Starting with the line having the bearing measurement. Starting with the line. So we go for this one. The question says ABCD is anti-clockwise. So it is okay. ABCD have been noted in anti-clockwise direction. Then you are moving in ABCD order, right? And the line with the bearing is AB. Line with the bearing is AB. So now you move to the traverse sheet. Right? So what you have to do, put AB here. Line with the bearing is AB. Then in your movement, next you go to the point B, and then BC, C. So here you look at the how easy to fill it. If I have put the numbers in order, then CD, D, DA, A, AB. And put B also as a check. So at the calculation we have to check. So I take a B twice and AB twice. So this is how I fill the first two columns. Now you also can fill it with me, right? AB, starting with AB because that is the line with the bearing. For the direction, I don't have to worry because AB, CD in anti-clockwise order. So I am moving along AB line, BC line, CD, DA. So at the end of AB line, I reach point B. Then I go along BC line to station C. After C, I go to the CD and D, DA, A, and AB. As a check for the last one, I put another B. Right? So this is how we can have to fill the first two columns. Is it clear? Any question? So this is very important in order to do the calculation, because everything would be systematic then. You can follow a particular system of calculation if you correctly enter the raw data. Any question? Okay. Right.